So the first topic I will kind of review last class. And second, it will be called tropical version.
Camera focused again.
Is it focused now?
No, there is very.
Okay, thank you. I'll try to, so it will be, okay. I'll correct it. Is it focused now?
Yes.
Just let me know. Focused, unfocused. So we will save some time. So here it's the tropical version of quantum field theory. It is classical field theory. So it is the topic for today. Well, if you know something about deformation theory, you will understand my analogy. If you don't know, I'll just give you an example. So what is a deformation theory? You study some object. We would like to study QFT, but you may study anything else. But you may study something like complex manifold, so here I recommend you to go to Liaison lectures later. But you may study. Or flat connection. So what is a flat connection? dA plus commutator AA equals to 0. A is a Lie algebra valued 1/4 on a manifold X. So you don't know how to study it. You don't know how to solve this equation. But what you know? A equals to 0 is a solution. Good. So we should study the full manifold space of flat connection. But we already have 1 point here, say 0 point. B. Small, take A to be epsilon A, where A small is a 1 form. Epsilon is small. So epsilon is small is how physicists are saying it. Mathematicians would say, consider problem in this space. Polynomial in epsilon moduli ideal generated by epsilon square. Plug it here. Then you have the easy problem, dA equals to 0. So we can solve this problem. We say that A is nothing but the closed one form. Closed Lie algebra value. One form. Is. But we are not going to study just this equation. We are interested in the full equation. So we say C, A is epsilon, and you can call it A1, plus epsilon squared, A2, plus epsilon cube, A3, plus etc. Okay? And then you plug it in this equation. You will get the following system. Maxim, is my video clear?
Yes.
dA1 equals to 0. dA2 equals A1, A1. dA3 equals A2, A1. That's it. dA4 equals A2, A2 plus A3, A1. Okay? Etc. So A1 being closed differential form closed Lie algebra value one form solves first equation. Now we are trying to solve the second equation. How to solve the second equation? I want to keep it on the board. A1, D of A1 and 1 is dA1, A1, maybe with a factor 2. So since this is 0, it is 0. So we conclude that the right-hand side of 2 is closed. The right-hand side of 2 is D closed. But what 2 is all about? dA2 equals A1, A1. So we demand it to be exact. there is an abstraction. And it's a map. It's a class of in second cohomology of X. So if there is an abstraction, we cannot go further. If abstraction vanishes, we can find A2, and then we can look about A3, A4, etc. This procedure is known as a deformation theory. So it was an example. But there is a general paradigm of deformation theory of everything. It says that deformation theory of something could be of the form Q psi plus M2 psi plus M3 psi plus etc. equals to 0. So when you would like to study deformation theory of something, you need to transform the problem in such a form, to such a form. And that's exactly what we did in this model of flat connection. And solution to linearized equations are called infinitesimal deformation. And the operations on two is called an abstraction. Now, what is interesting? It is interesting that quantum field theory is like an other objects in mathematics. It has a deformation theory. So infinitesimal deformation are given by local observable or defects. Local means associated to a point. So we moved from functor applied to x, it is promoted, to functor, and here we have x And here we have pi at point P, where P is a point in X. Now, space of local observables are deformations. And then the question is, what is the abstraction? Or what are abstractions? So we have QFT 0 or just F. We have then F of X phi P. Now we define F deformed as F0 of X or just F of X. Sorry. Plus epsilon F of X phi P integral for when P goes all over F. It's okay.
Excuse me. Can
Yes.
I just want to know if epsilon is independent of x.
Of course, epsilon is just parameter of deformation. Epsilon is a formal parameter of deformation. So I want to have quantum field theory. I want to study family of QFT. So what does it mean to have family of QFT? So we need to consider functor applied to X and epsilon. Okay? That belongs to, let us see where does it belong. It belongs to homomorphisms from V in to V out. Okay, I call them L or V, I don't remember. Times functions on geometry of X times formal power series in epsilon. So it's important to know what we are talking about. We are talking about exactly this object.
There were some differential forms, no? In f at x epsilon.
So
F at x phi at p is the differential form dimensions of x.
So at the moment it was f of x epsilon. Now let me understand what is fx phi of p, where x phi of p lives. So here I have epsilon. Here epsilon is outside. This epsilon is not phi of p. Okay? I want to take f of x epsilon to be f of x plus epsilon integral. And here I take p. And here I want to do something like this. Plus epsilon squared, maybe over 2. integral of p in x, p prime in x. And here I want to put f of x, phi of p, phi of p prime, plus etc. So this is the deformation of quantum field theory.
Okay, thanks.
And whenever I'm writing it, I want always, I want you to remember example. For d equals 1, e to the t h plus epsilon phi, it is a deformation, equals e to the th plus epsilon integral from 0 to t e to the t minus t tilde h phi e to the t tilde h plus 1/2 epsilon squared integral from 0 to t and then here will be no half integral from 0 to t tilde, here integral over t tilde, here integral over t 2 tildes. Now what I'm writing? So here I have local observable inserted at 2 points on an interval. 0 t, it is t tilde, and this is t2 tilde. And I integrate over t tilde from 0 to t, and I integrate over t tilde from t2 tilde from 0 to t tilde. So it is not actually, it's example. However, there are abstractions in this business. Such integral may diverge if goes to infinity when p go to p prime. And this is phenomena of the ultraviolent divergence written in this language. And this is exactly obstruction. So we would like to deform to the second order in epsilon, but we stop.
Can you explain why it is related with UV divergence?
Okay, sure. I need to check time. Yes. So what UV divergence means? UV divergence means that when you go to small distance, the integral diverges. Okay. I will explain it Just in a second. But I need some model. Consider D equals to theory D mu phi square plus epsilon phi to the power 4. Okay? Now we have epsilon to the power 4 at point P and epsilon to the power 4 at point P prime. And we denote them like this. Here I have P, here I have P prime. And it happens under correlator. So then what I'd like to do, I need to put here propagator. Okay, in this case, this may be too easy. So this propagator is 1 over k squared. Okay? That corresponds to log. So this example is too simple. Because if I have here log, it would not diverge. I'm sorry, let me change an example.
Why there is log? We consider it dimension 2.
In dimension 2, I say in dimension 2. Okay. Okay. Consider D equals 4 theory. Okay. Plus epsilon phi to the 4th. Okay? Then I have PP prime. And then in momentum space, I have a loop. And I have K and K prime that are momenta. So here there are some external momenta, like L1, L2, L3, L4. But it's not what that I'm interested in. Mostly, I'm interested in the integral over D4K, 1 over K squared. And here I have K squared plus or minus plus some L squared. So this L comes because of external lines. And this,
we have K plus L in square.
yes. So we have something like K plus L square, yes. But what is interesting is that I have logarithmic divergence. And that's what people call UV divergence. At the same time, in coordinate space, this diagram corresponds to Z, okay, to XP minus XP prime to the power 4 squared, and another XP minus XP prime to the power squared. Because these green functions correspond to such kernels. And here I am integrating over d for xp. And here again I see logarithmic divergent integral. When xp goes to xp prime. So this is an example that you should keep in mind. Okay, I want to go strictly according to the clock. I don't want to start new topic before we will clear this topic. That ultraviolet, so moral is ultraviolet divergences are abstractions in the theory of deformation of quantum field theory. Maxim,
Yes,
please ask a question.
I need to think sometime before I ask the question again.
Okay, good. Now we will have a 10 minutes break. So first part was a bit shorter. But you see, idea could not be always cut into pieces of exact time. Okay. Second part of my today's talk would be longer.
You announced some tropical
Yes,
geometry.
yes.
Okay,
But this topic would be after the break.
okay.
And we will have a 10 minutes break and then probably up to 1 hour. When I am answering questions, I have to answer using something that I have not explained. So I apologize. But otherwise, I would say just remember this, remember that, and I'll explain it to you in logical way. But it would delay my answer. Okay, so now let us go to tropical stuff. So it starts with the tropical algebra. And topic number 1 would be formal tropical algebra versus limiting. So let me start with formal tropical algebra. What I'd like to consider, I would like to consider semi-ring. With 2 operations. Operation number 1. So I say that positive number positive, I would say real number. Form semi-ring with 2 operations. First operation is multiplication. A tropical. tropical multiplication. B tropical is A plus B considered as a tropical number. And this is sum in R. Second property. So probably I still should put here not real but positive. I'll see it. Second property, no, real. Second property is addition. A tropical plus tropical. B tropical is maximum between A tropical and B tropical. Statement. The statement says that it is a ring. So, what does it mean that it's a ring? It means that A tropical multiplication tropical by C tropical is A tropical times C tropical plus B tropical times C tropical. So now let us check if it is true. And of course, here you can easily check commutativity, associativity, and also here commutativity and associativity, and this is distributivity. Okay? And this is axiomatic or formal approach to tropical ring. So we take real line and we just define two new operations. One operation is actually an old operation. It's just addition on the real line. Nothing new. However, this operation is kind of new. Now, and there is also limiting point of view. Limiting view on tropical ring. It says the following: let me take A and let me take H bar, a real number, a positive number. And then let me do the following. Let me take A to atropical, that is the following thing. Just 1 second, I need to spend some time. Atropical is H logarithm A. Or in other terms, A is e to the 1 over H atropical. Then 1 is obvious. So let me call it tropical H. So then property 1 is obvious. Property 2 is not obvious. So let me do the following. Moreover, property 2 is not wrong. Property does not hold. However, two is true in the limit H bar going to 0.
Property 2, it's about addition.
Yes.
Mhm.
So if I take addition of A plus B, it is e to the 1 over H ATH plus e to the 1 over H BTH. Now, let me take H going to 0. In the limit H going to 0, having this term fixed, I can say that only one of these two exponents is important. And it is the exponent where this guy is maximum. So I don't want you to hurry up. I want you to understand this phenomenon.
Could I ask a question in Russian?
Sure.
Я правильно понял, что вы сейчас сказали, что в пределе h, стремящемся к бесконечности, мы имеем в виду, что вот эта штука максимум из А и Б, в смысле, какая экспонента медленнее вымирает?
So H goes to 0, not to infinity.
То есть, ну, в смысле, да, к нулю.
So when H goes to 0, you see, I am not saying that they are going to 0. They could go to infinity. But one of these terms is much bigger than another term.
Вот, я это имел в виду. Thank you.
And that's why we are getting tropical ring in this limit. So atropical is a limit of ATH when H is going to 0. And this is a limiting approach to tropical semi-ring. Now, let me tell you something very important. We can write down quantum field theory with values in tropical ring. So it would not take values in ordinary numbers, because elements of the tropical rings are not numbers, okay? They are elements of the ring. I hope it is clear. It's a some algebraic structure, tropical ring. But, you know, like we may have polynomials, and we write polynomial of x1, xn. We can put here any ring to have polynomials. Similarly, when we say that we have linear algebra, we say that elements of the space L are xi, okay, I'll call them vi, ei. We call this basis. And these typically belong to a field R or C. But now we consider Vi belonging to tropical ring that I'll call TR. So I have a concept, new concept. It is a tensor algebra over EA. Okay? So now let me give a definition. Classical quantum field theory is a QFT, is a functor from geometrically enriched covariance to tensor algebra over tropical ring. So the title of my course was Quantum Field Theory with or and without Planck constant. Okay, I started with giving definition that has had no Planck constant at all. And here I'm explaining something about the space where the Planck constant is exactly zero. let me construct such a function in the dimension 1. I will do the following. I will take classical mechanics. I have to remind you what classical mechanics is. So it will be example. So classical mechanics is the following set of data. The space, so people used to call it phi, but I will call it y. Space. It is an even dimensional manifold. Equipped with a 1/4 alpha called potential for a symplectic form. Omega equals the alpha. Such that omega is non-degenerate. It means that I can take omega minus 1, it is pi, and this is Poisson bivector. Okay. Now let me remind you that given a function, h on y, I define so-called Hamiltonian vector field VH, called Hamiltonian. EVH, iota VH, inserted into omega is DH. Or in components, V mu H, omega mu nu is V nu H. And classical mechanics studies trajectories of VH called classical solutions to equations of motion. Okay? Now, let me try to do the following thing. Definition. Suppose that dimension of y is 2n. A n-dimensional submanifold L inside y is called Lagrangian if omega restricted to L equals to 0. Now example of everything. Y is P star to R. Here coordinate is X, here coordinate is P. Alpha is P dx. Omega is dP dx. Let us take H. P squared plus X squared. Then vector field V has the following components. P minus X. So equations of motion have the following form. dx over dt equals P, dP over dt equals minus X. So that's what I call mechanical system. Sorry, I need to take a 2 minute break. I want to correct myself just a little bit. I want to put here coefficient K. And that's why I'll have this. Now, I need to construct this object called classical QFT. Let me take the following. Consider a infinite dimensional space of Lagrange submanifold. So all one-dimensional spaces are Lagrangian. In this example, and call it lag. Okay. Now consider space V as a space of functions on lag. Now let us do the following. Given all this data, and an interval 0, t, I will construct the function that would belong to function on lag times functions on lag times functions on R plus. So this would be V, and this would also be V. I just need to explain how I am constructing this value. I have L1, I have L2, then assume that I have unique classical trajectory. And then factor equals classical action on classical trajectory. Trajectory connecting L1 and L2. Now, why it is a function? We need to check functoriality conditions. However, it is easy. L1, L middle, L2. I have here classical trajectory. I have here classical trajectory. And then the classical trajectory that goes from L1 to L2 is a union of these two classical trajectories. So really, so am I right or not? I need to define composition. Because, no E. S classical, L1, L middle is one thing. I also have S classical, L middle, L2. But then I will do the following. I will take the sum. And from this I need to go to S classical of L1, L2. How do I do it? I will consider sum and then I take the extremal value of this sum along line. Sorry. And this is from triviality. Now let us check how it goes on an example. Example. K equals to 0. Let me take L1 be the following. Be the following Lagrangian manifold. X equals to x1, E is arbitrary. Let me consider the same for L2. X2, P is arbitrary. And also for LM. So here is this long interval. If I fix x1, x7, oh, by the way, the action is p x dot plus p squared. So classical equations of motion are p is constant, and x dot is, okay, p over 2 is p. I think I would like to put something like minus here. Now, S classical is what? X of t on this interval equal x1 plus xm minus x1 divided by tm, and here I have t. So p is m, so it's tm. P is m, xm minus x1 divided by tm. S classical is m over 2 xm minus x1 square, and here I have tm. I also have S classical 2. It's m over 2 x2 minus xm square, and here I have t minus tm. So I work with this interval. So interesting question is, what would be if I add S classical 1 and S classical 2, and I consider their extremal value along xm. So what will I get? This computation is so important that I don't want to do it right now, when you are tired, when I expect you to be tired. What I just told you is in folklore. Unfortunately, I cannot pick up the proper reference. So many people discovered it for themselves. I mean the tropical meaning. And it is better if you do it together with me. And now it's time for questions. Maxim?
I was thinking about questions, but I a little bit staggered. В общем, в растерянности я думаю пока что. У меня как
Чё вы
только образуется
думаете?
вопрос, я говорю, в растерянности я пока думаю. Как только у меня образуется вопрос, я вам сразу напишу. Я не могу так быстро придумать вопросы.
Okay, so since I'm telling you new things, new material, I am not rushing, okay?
Yes, okay.
We will do several examples on it.
I remember question which I want to ask some time ago. It's stupid question. Why tropical is same ring and no ring?
So let me think. It depends on where you define it. So we defined it on real numbers, right?
Yes. I saw definition in Wikipedia and they defined it only at real numbers and called it semi-ring. But I
Good.
think that it is field because all elements have opposite.
It's definitely not a field. And okay, it is semi-ring because the addition, because it is not a group by addition. Wikipedia is great, but
Addition, you mean tropical addition, which
yes,
maximum of
AT plus BT
Mhm.
is maximum AT BT. So it is not
Okay, yes. I
an
understand.
abelian group. So here you have associative and commutative operation without the concept of 0 or 1. And if you don't have a concept of 0 or 1, you cannot even say that it is a group. And in the standard definition of a ring, people say that we have two multiplications and one multiplication forms a group, abelian group, and it is called plus operation.
Yes.
While product operation, multiplication, is just associative and distributive. Okay?
Mm-hmm. Okay.
So next time I'll tell you more about this example. Okay? And I hope that by Tuesday we can make some, not recordings, some texts, okay? Some notes. and we will send it